Hello, everyone. Welcome back. I hope you've had a chance to go get yourself a drink now. We're packing it in today. There's a lot to discuss and a lot to hear about as well. So I hope you're enjoying this talk so far. Do keep your comments coming in the chat as well. If you have any questions for any of our panelists, things you want to discuss, we will welcome any kind of conversation there too. And before the break, we were asking people what they thought were particularly inspiring projects out there. And it's great that there's so many projects that are out there to inspire people. So we've had mention of the Dickens Jones Online mentioned already, the Dickens Letters project we've heard about as well, which is fantastic as a way to complement the published volumes, having new letters added on there all the time as well. There's been mention for the Druid Inquiry, which somebody set up. I don't know who that was, but that's also another interactive website looking at Edwin Drood there as well. And then there was the tweet along as well, done for our mutual friend, which I had great fun being involved in too. And with those projects, these read-alongs as well, there's this, again, going back to the idea of interaction, of how we can involve people. And actually, for all the idea people want to be passive, the reality is that people engage much better when you're asking them to contribute, rather than when they're passively just receiving information as well. That's what the internet offers, after all, rather than a book. And so ways to embrace that are really ways to increase the traffic on any of these sites. And I'm particularly intrigued to have read about the Astrid Lindgren site as well, who wrote all the books in shorthand at this point too. So that's a whole other shorthand transcribing website there in the chat to investigate and find out more about too. And I suppose what we're finding out of all these amazing project plans that go forward is thinking about how we can connect them up as well. All these projects have been done individually by individual universities and people there as well with different funding. But as we move forward with academia and internet, how can we better connect together these projects so that people can look at deciphering Dickens and then go on to look at Dickens in shorthand as well? And should we be thinking more, not just about sustainability and maintaining these sites, but also how we can connect them together as well, if we can do that too. So these are things that we can think about as we more and more get into the idea of internet sites being the norm as much as publishing books. Are we fully using them as well as we can do? Can we make more connections across sites as well to increase traffic, correspondence, and joined up things between those as well? Now, while I've been going on today, Lydia has been handling the tweets. Hello, Lydia, my co-host today. How are you? Good to see you. Okay. I feel like we're doing it's kind of like, a charity-thon or something. We'll put the number on. You can call in and vote in now. Lydia, how's it going on Twitter? What's going on over there?
So, Pete, we have several new followers, which is exciting.
Excellent.
Yeah, people are going for it, especially the last two panels. I think seeing all the links, knowing that there are things they could do to get involved. Just lots of retweets, likes. Also, the old joke archive probably comes on top. People apparently really just love a good or bad Victorian joke. So I think there'll probably be several new followers for the new account there as well.
Excellent.
I did not put anything about Bentham's body in the discussion of the transcription for that project, but I was very tempted to, and I might add a little informative bit there for the less morbid of us, I suppose.
Excellent. But football, perfect.
Yeah, things are great. Continue to retweet and like, and we have a panel just coming up, so I'll be live tweeting that as well.
Thank you very much, Lydia. So what we've had so far, then, we've had 4 panels now today, and the first 2 panels this morning really focused on shorthand. We learned about the history of shorthand and Dickens' involvement with that as well. And then we looked at some of the archives from around the world and museums of shorthand materials there to look at too. Then our last 2 panels are focused more on the digital side of the project, of how we can crowdsource for these funds, for these projects as well, and what other previous projects have learned about the idea of crowdsourcing and updating information as well, and using manuscripts and text there as well. So in our previous panels, we've now learned about the digital side and all the shorthand side. For our final panel of the day, which I believe Hugo will be introducing our chair Leon for, we're going to learn now about Decoding Dickens and how all this comes together at last, and looking at shorthand and digital together to hopefully find a way to at last decipher this remarkable collection of Dickens' shorthand works. So I think we're over to Hugo. If you're there, if you'd like to take over. And for now, guys, thanks very much, and keep on your comments. Thank you.
Okay, thanks, Pete. Thanks, Lydia. You've done a great job. Now, our next panel is one I've been really looking forward to. It's called the Decoding challenge, and it's going to be chaired by Leon Litvack. Leon is Reader in Victorian Studies at Queen's University Belfast and Principal Editor of the Charles Dickens Letters Project. And he's the leading authority on Dickens's correspondence and handwriting. So over to you, Leon.
Thank you very much, Hugo. I too am looking forward very much to this panel because it offers an interesting marriage between the manual and the material and the digital. And so I hope that these two papers will unravel a number of mysteries for us, and will also give us some ideas about how we might go forward, and particularly how to use machine learning and forensic linguistics in order to serve as adjuncts or aids to what we already do. I don't think it'll ever replace the more cognitive, or maybe even the more sensitive approaches that we have towards language, towards paper and handwriting. Of course, we're entering an age now where cursive script is fast disappearing from our schools. And so that really is a problem for anybody who is involved in the transcription of handwriting. You can imagine that in future this will become rather a specialist area rather than something that we can take for granted. But we're not there yet, so we still need people who specialize in handwriting, which means that I still have a job to go to from day to day. Okay, well, I'm going to hand over to Claire, because Claire is now going to introduce us to the shorthand mystery.
Thank you so much, Leon. And Hugo, if you don't mind sharing that slide again so we can all see that wonderful letter on screen. Terrific. So I'm actually going to keep my remarks here really brief so we've got more time for the two speakers who follow. And I want to introduce this fascinating and puzzling manuscript in the collections of the Morgan Library and Museum. Now, as you can see from the image, this document is written on Tavistock House headed notepaper. Dickens lived at Tavistock House between 1851 and 1860, which is suggestive in terms of the dating of the letter. At least it gives us something of a range to work with. While we assume that this is a document authored by Dickens, it's important to say that this has not been proven definitively, for example, through analysis of the handwriting, the ink, or the paper. And Leon, you might have some interesting reflections here on how we might go about that. The document is written entirely in shorthand characters, some of which we can clearly identify from the Brachography Manual and Dickens's shorthand notebook at the John Rylands Library, which John was showing us earlier. When we look at this, the paragraphing is suggestive of a letter. So this could well be a draft letter for which a longhand copy survives, a letter we might find either in the Pilgrim edition or indeed on the Dickens Letters Project. But there are no longhand indications of who it was to, what it was about, and when precisely it was written. We are, however, fortunate, and this is a particularly clean copy. Nearly every shorthand character is being shaped with care here, with an effort to preserve the lineation, so the lines on the page, and to render the distinct characters clearly. This might indicate that the document was intended as a teaching exercise for one of Dickens's shorthand pupils. But again, we don't know this for sure. And as Tim has said earlier, context is all. We can get so many hints from really understanding this letter. The clarity of the characters also makes this letter particularly good for decoding, and it's why we decided to pick this for our prize decoding exercise. Nonetheless, we're still faced with the inherent difficulties of deciphering Gurney script that Hugo was outlining earlier on. Without an identified source text, we have to puzzle over the interpretation of each character and line and wrestle with all of those fascinating ambiguities that arise. Hopefully I've whetted your appetite. I'll leave it there for now and hand back over to you, Leon. Thank you.
Thank you very much. So we hope that our next two papers will be able to offer us further insight into the mysteries contained in the Tavistock letter. So I'm first going to introduce very briefly Zhou, who is professor at the School of Informatics at the University of Leicester. And he's going to speak to us about, can machines crack the Dickens code? Thank you.
Thank you, Leon, for this introduction. I also like to thank Claire and Hugo for inviting me today. And what I'm going to do, I'm going to share my slides. So can you see the slides? Excellent. And what I'm going to do today is I'm going to share my experience on this topic. Can machines crack the Dickensian code? My name is Zhou from the School of Informatics, University of Leicester. To begin with, I'd like to outline our research questions here. And as we discussed the Dickensian code in the last 3.5 hours time, I'm sure that every single one in the audience knows what is a shorthand. The shorthand, in fact, is a very important part of Dickinson's writing. And however, we know a little bit about this, how he did so, how he did this Dickinson's code, why he used this code to write up his most of the books, so on and so forth. And in this project, we wish to collect and digitize and decipher all the items of Charles Dickens's shorthand. This is our target. In this particular place, and we are looking for a machine, intelligence machine, to do this job for the human being. Whether or not we can do that, we haven't got the answer yet, but we will see. And why this question is so challenging? There's quite a few different reasoning. I think Hugo already mentioned this in his speech before. The system of the shorthands used by Dickens is very difficult to interpret. One of the reasons is the shorthand used by Dickinson is based on a Thomas Guinness brachistography. And this system is quite difficult to understand. On the other hand, Dickinson, he also changed the Guinness system and adapted the system for himself to use. On the right-hand side of the screen, and in the middle column, you can see it is this example from this Dickinson's code. On the most right-hand side, I posted quite a few people's comments on top of it. By Jenny, you can see this fractures the codes in Dickinson fiction. And also Hugo's pointed out by the end of the 19th century, it's very hard for people to understand, to read the Guinness shorthand. And you can find a lot of examples on Google Internet. And before we talk about the machine's intelligence, we would like to ask how the humans interpret this Dickinson's code. On the screen, I show you this example. On top of this screen, I show you that quite a few strange characters. And this is a shorthand written by Dickens. And first, what we need to do is, as human beings, we got this Dickinson's code, and we're going to translate this Dickinson's code into English characters. Once we got these English characters, then we're going to use some small intelligences, that kind of things, to build up the meaningful English words. And if you want to summarize what a human doing here, and first we want to segment this text document into different lines, characters, and then words. And afterwards, what we do is we use a dictionary. This dictionary is prepared by a human being. And then we register this individual characters to the corresponding English word. This is what we do as a human being. And you probably ask me then, as we already know how the human beings interpret this Dickensian code, then whether or not we can simulate these human beings doing and try to produce some machine intelligence and try to produce some of the tool, and that can be the implements on the computer to recognize the Dickensian code, things like that. And here is I'm not going to show you the Dickensian code and decoding system. I'm just to show you some general case. And this is what we use a machine to crack the different tests or different pattern, things like that. A standard machine learning-based documentations and recognition system should look like this. I think this is a general strategy framework and can be applied to different scenarios, including this decoding of a Dickensian code. The first stage and first step that we can do is we can look at these images we collect from the manuscript of Dickens, and then we binarize these characters. The reason why we do this binarize because we want to single out each single characters from the background. And once we have done that, then we use something called a blob detection. The blob detection is allow us to detect the characters one by one. For example, the X, I, E, N, S, so on and so forth. We pick up the individual characters. Once we got these individual characters, we use the distance matrix and which one is connected to which one, and so on and so forth. And then to train up all the characters to formulating these English words, right? Once we got these English words one by one, then we can use some sort of advanced technologies called a GPT-3. The GPT-3 is a very novel technologies tool produced in 2020, last year. This GPT-3 actually based on deep learning architecture. And then this tool is actually can be used to produce meaningful English word from characters. Therefore, once you got these individual characters on the bottom of these slides, and then we use the GPT-3 to line up all the English meaningful sentences. So previously I discussed how to use a machine learning tool to recognize and decode Dickens's code or the other similar problems. Then now we want to point out one research study on the conversions from the this is the Greek shorthand to English word. And the reason why we use this example because this is the only example I can find from the literature, and I think that they have a similar context to ours, and that would be useful to know what they're doing, and then what is shorthand and or the weaknesses in their system, and then we can accordingly build up our system, things like that. Before we discuss these technical details in this research study done by the other people, I'd like to give you a comparison between the Greg and Pittman's shorthand. The reason I do this comparison here is because in that study, the authors compare the Greg's and Pittman's shorthand. We know that these both systems belong to a standard system, and they're quite similar, look similar in terms of the code. The Pittman's looks like it's pen freaks. If you look at the right-hand side of the screen, you can see this Pittman's code is quite formal. And in the meantime, the Greg's shorthand seems to be a little bit handwriting. It's a bit of draft and things like that. And also, we can recognize that Pittman's shorthand that has many broken lines, dots, and dashes, and it's difficult to learn from this. And this is the system proposed by Padillas in 2020. These groups actually produce algorithms for Greg shorthands word to English words the conversion using the deep learning. Actually, what they do, they use a deep learning architecture called inceptions V3 in the right middle of this page. The left-hand side is the inputs from the Grexter shorthand, and the right-hand side is the English word. And this is the pipelines proposed by the Padillas in 2020. The outcomes of their systems looks like this. The translations that result from the Grexter shorthand to the English words and success rates around 57%. Why, you probably ask me, why do we got a so low success rate? This is because if you look at the right-hand side of this screen, the shorthands, the Grexter shorthands image on the first column of the table, and you can see there's actually the translation should be complete, falling on the second column of the table. However, we got this mistaken because on the fourth columns, we have the equivalence to the shape from the Grexter shorthand. So actually, this indicates the course. Okay, this is because these are the two shapes. The first column and the final columns that looks quite similar. And maybe you don't think these are too similar on the first, on the second rows, but on the third rows, the first column and the final column, they actually looks very similar. So this is why they got this mixed up between the commits and conveyance. Okay. And well, that's a very short 10 minutes introduction to what we think about the machine learning based decoding system. I'm just doing a quick summary here. We discussed the challenges of the decoding shorthand, and we also review a standard machine learning scheme for deciphering the shorthand. And we also introduced and published the machine learning algorithms by other people for deciphering the shorthand. And currently in my research team, we have prepares the technologies there. In our team, so we have lots of people working on deep learning, and which are holding the similar architecture as we showed in the inception briefly. And hopefully we can apply the technologies developed in our team to this decoding the Dickinson's code, hopefully. Thank you very much.
Zhou, thank you very much for that fascinating brief insight into the system that you are currently developing in order to examine particularly established, widely used methods of shorthand transcription. I suppose that the challenge in the case of Dickens, as we have heard earlier on today, is that some of his representations are quite idiosyncratic, and we know some of them, like electric telegraph, but not necessarily all of them. And so I think the challenge will be, how do you translate something that is standardized, like Pittman or Gregg? How do you compare that to a more idiosyncratic system where Dickens was basing what he said on what he was using for shorthand on an established system, but he had his own idiosyncrasies introduced as well. I'm sure that will prompt many questions. So please feel free to ask them in the chat, and we will get to them after our next paper. So I now would like to introduce again very briefly Andrea Nini, who is a lecturer in linguistics and English language at the University of Manchester. And he is going to be speaking about forensic linguistics and shorthand decoding. Thank you very much for joining us today.
Thank you. Thank you for inviting me. Just 1 second, and I'll share my slides. Okay. Can you see it?
Not yet. That's better. Thank you.
Okay. Fine. Okay. So I'll be talking about forensic linguistics first. So I'll just say a few words about forensic linguistics, what it is, and then I'll move on to the decoding task. Right. So I'm assuming the audience might not be familiar with forensic linguistics and potentially even with linguistics. So by linguistics, what we mean by linguistics is the scientific study of how language works, which can be in society, in the mind, in culture. There are different approaches which are reflected in the various subfields of linguistics, like psycholinguistics, sociolinguistics, and so on. And linguistics can be theoretical, so it can be targeted to understand how language works, or it can be applied. So you apply that knowledge to solve real-world problems. And there are various applications, and one of them is forensic. Forensic meaning concerning the law. So this is something that I sometimes tell my students, that actually forensic linguistics doesn't really exist in the sense that it's all linguistics. It's linguistics that is applied to a certain set of problems. We can also talk about two types of forensic linguistics, really. So the study of how the language of the law works, how and why we write laws in a particular way, and but more, I would say, more associated with the word forensic is the other area, which is the study of evidence. And this can be of things like, for example, interpretation of meanings in contracts, for example, or trademarks, or trademark dispute which involve language. It can concern voices, so recordings that are unknown. Or finally, which is my area of specialization, it could be about disputed authorship. So for example, there is a particular letter. This is a letter from the Zodiac killer. And the question can be either there are, say, two suspects, and in this case, let's say the police collected writings, their writings, and so it's a comparison of authorship, or it could be profiling. So it could be about extracting knowledge using linguistics from the text to say something meaningful, useful for investigations about the author. And let me just stress that this is not about handwriting, and it's not about the use of ink or other aspects of the text. It's all about language. So it's all about the grammatical constructions and the words that are used in these texts. Okay, so as you can see here, decoding is not something that actually, I would say, can be one of the main areas of forensic linguistics. There have been a couple of cases that I know about that concern decoding. One was that I can't even quote what particularly the case was, but it's what about a diary that was coded by a teenager. It was written in a code and became part of the evidence in a case. And also there are prison letters, so letters that are written by inside a prison, they are sent outside, and so they are written in a code. But usually this code tends to be quite easy to crack, and also, more importantly, takes me to this distinction that I wanted to make, coming from Oak's literary detective work on the computer. There is actually a distinction between decrypting something and on the one hand, or deciphering something. And decryption, I'm showing the example of the Enigma machine here, you probably remember. It's really an area of mathematics. So it's the application of mathematics and logic to crack a code, which is adversarial. So it's something that has been intentionally hidden. And once you find the key to unlock it, then you're able to read the underlying text, which means that you also know if your solution is right. because if your key works, then you have something that makes sense. Now, decipherment is, on the other hand, it's really an area for linguistics, because decipherment is about often ancient languages. And the example I am showing you here is the hieroglyphs. And they tend to be solved, like for the hieroglyphs, using a parallel text, which in that case was the Rosetta Stone. But it's really an area of linguistics because language is not a mathematical code. So you have to make sense of it in society, in culture. So you cannot just find a key that will decrypt it. And also, decipherment is not adversarial, meaning that the fact that we see the particular text written in an unknown script, it's just because we lost memory of how to read it, essentially. And that also means that in the majority of times, you don't really know if your solution is correct. I mean, if it makes sense, it's probably correct, but because you don't know the context of that particular text, you don't know if it's a recipe or a set of instructions, then sometimes it's hard to decide what interpretation to go for. So I think in terms of the Dickens shorthand, it's probably, we're talking about decipherment really. Although it's a bit, it's kind of an odd case of decipherment because there is some element of adversarial character in shorthand, which I didn't know before, like something that I learned today. But largely it's about decipherment. So how do we tackle decipherment? Well, I don't think forensic linguistics can answer this question, but linguistics could. So if we use principles and methods from linguistics, I think we can do something that could be useful. So even though I cannot really answer to the question what the field of forensic linguistics would do, I can at least say what I would do if I were to address this problem. So the algorithm that I would follow, the list of steps that I would follow would be, first of all, to transliterate a text to something that is machine readable. So to break down each of these symbols to the smallest possible unit and transform it into something that a machine can read. And I'm inspired in for this particular step, from all the work that has been done on the Voynich manuscript. I don't know how many of you know about the Voynich manuscript, but if you're interested in mysteries and ancient manuscripts, this is something. It is definitely something you want to have a look at and search on the web. So you can see this image here. So the Voynich manuscript has been written in this script, and no one really knows what it is. So there are all sorts of theories, including that it was written by aliens. And what I was saying before about decipherment being you don't know whether you're right or not, is that there are people that actually found solutions to the Voynich. Actually, every 6 months, there is someone who claims that has solved the Voynich manuscript. And they produce things that make sense. But of course, we don't know if it actually makes sense or not, because we don't really know anything about this manuscript. Anyway, so there is a very hardworking community on the Voynich manuscript. And one of the things they achieved is they created the extensible Voynich alphabet, which is essentially a way to transform all of the symbols in the Voynich manuscript into characters that can be read by a computer. So in other words, what you have is something like that. So you have a plain text file that contains something that you can work with using computational methods. So, the case of Dickens shorthand, it's not as clear as the Voynich, because the Voynich, for real languages, a symbol can be usually either a syllable or an ideogram or a letter that is phonetic. For Dickens shorthands, a symbol can be either a letter, or it could be a cluster of letters that contains information about the vowel, or it could be even a root. So, for example, here, justifying and all the other morphological variants, or even a combination of the above. So there might be a symbol that it could be interpreted, depending on the context, as a word or a letter. So it is actually a bit more complicated than the normal decipherment. However, we have some symbols for which we have a starting point. We have a Rosetta Stone of Dickens, right? So even though it's only partial. So the first step would be to use them as a starting point, I would say. And maybe Gurney can still be used as a starting point, because there are similarities. So again, that would be something that should be done. And I think the contribution of linguistics would start at this point, because using this initial information, I believe we can potentially look at exploit what we know about the statistics of language, and potentially even study the statistics of Dickens language and knowledge of how grammar works to disambiguate the symbols that we don't know. And this comes from, most of this knowledge comes from this field called corpus linguistics, where corpus is a collection of texts. So corpus linguistics is this branch of linguistics that studies how we analyze a lot of text together using computers. As Hugo says in his paper, so in the case of ground, so we can correctly identify the sequence of consonants, but we don't know whether it's grind, grind, or groan. Well, if you collect a corpus of 19th century English, and maybe you add Dickens corpus, so we have lots of data from Dickens, so we can collect all of that. Then you can actually estimate, you can give it a probability of a particular word following or in a certain context. Because, for example, it could be that, just a wild example, it could be that Dickens never used grind, ever, right? Or that he preferred another, a synonym of that. So we have ways that, and also let's not forget that we can still use the grammar of English to disambiguate some of these words. So some of them at least can be ruled out. The other thing, I don't know how much time I have, but I'll just go through this very briefly. So the way language works, there is a lot of statistical information that we can exploit, right? So for example, Zipf's law says that if you count how many times word occurs and you rank them by frequency, then the frequency of a word is inversely proportional to its rank. What this means, and for any language, this applies to any language and any corpus that is sufficiently large. And what happens is that, we can rephrase this in another way, which is that in any language, there are very few words that are very frequent and lots of words that are very infrequent. And the words that are very frequent in any language are function words. So things like pronouns, articles. And most of any text or any language is made up of words that occur only once, which are called hapax legomenon. So in other words, by just making a frequency list of these symbols, I think we can already guess what symbols, for example, are words and what symbols are letters, right? So just by making a frequency list. Then there are other tools. Frequency list of symbols would be a starting point, I think. And there are other tools. So for example, a concordance, so you list all of the examples on like a table in context. And then you can see if there are any patterns, right? You can spot any patterns, any irregularities in the way that these symbols appear. Or collocation. So I would be shocked if there aren't symbols that tend to co-occur with each other. And that can tell us something about the way, it can tell us something about what these symbols represent. And of course, even things that are a bit fancier, like analysis of constructions where you have a symbols with a variable slot. But again, so the idea here is that, just to recap, the way I would approach it is transliterate it into machine learning, sorry, not machine learning, machine readable version, and then use the tools of corpus linguistics to help the decipherment. So in other words, what I'm saying is that what we need probably is a computer assisted approach, so that the computer can aid the human analyst. Okay, thank you very much.
Thank you very much, Andrea. I'm glad that both in your paper and in Zhou's, the human element has not yet been removed. So it would seem there has to be some human discernment initially before you allow the whatever software you are using, whatever kind of machine learning you are using, in order to take you that that little bit further. Just a couple of observations before we open it up for questions. And Hugo has referred to this in the chat. We don't have many examples of Dickens's shorthand, and in a way that presents a kind of issue in terms of the size of the corpus. So because the corpus is small, we may not have a sufficient quantity in order to make some of these things work. And just an observation to do with the Tavistock letter, and that is we do of course have thousands of examples of Dickens's correspondence, and if the Tavistock letter is in fact a letter, then the letters have been digitized, the corpus of letters has been digitized, and you can use that to offer comparison to what is present in the Tavistock letter in order to help with transcription. Now, I'm going to go back in the chat to Hugo asked a question initially, and I think maybe we have answered it. And he asks, is the Gregg machine learning impossible for Dickens because you need a lot of shorthand for the machine to process, and for Dickens we have very few manuscripts to work with? So maybe I'll ask Zhou that question, because if you're trying to use what you presently know about Gregg and Pitman in order to approach Dickens, how much Dickens do you need in order to make this work? Do we have enough?
Excellent questions. Excellent questions. And we did have a words with Hugo and Claire before. And when we discussed this type of problems, I think so at that time we probably have collected around a few hundreds Dickens's work or the similar code. And the problem is, and if we wish to enable the deep learning architecture to properly work, then we need the thousands and thousands the training examples. To meet these requirements, I guess the best way is, and we have to manually to create this synthetic data, which they contain a different shape, a different kind of the strange behaviors from the Dickensian code, so on and so forth. To do that, and this is what I'm going to put in the communication channel, and we need to use something called augmentation technologies. Augmentation is referred to the data augmentation, and all these type of things then has been available in the machine learning field, and we can take advantage of these technologies. And then once we create the sufficient example, I don't know how many we're going to use, how many examples we're going to create, which then turn out to be sufficient, I don't know. However, the advantage we have here is, and we have the supported the technologies now in the team. We also have the people working in relevant areas, and I think what's the matter next is that we're going to create a number of the samples by repeated doing this type of augmentation and see how it goes. And however, I cannot send the specified number to you because it's still an ongoing research project.
Thank you for that honest answer. That was very good. I think we probably have time for one more question, and then if I ask the speakers to maybe respond in the chat. So Kelly has asked, an observation she makes. She says, one of the biggest difficulties that I've encountered in shorthand decipherment are characters that could be interpreted in a number of different ways. I think this is maybe a point for Andrea. The character for S might look a lot like the digraph for KR, for example. Could you perhaps speak about how you would handle that kind of ambiguity?
I don't know. No, I would say probably the solution should be to go back to the minimal unit possible, right? So in this case, it would be, what was that? So that was, well, we don't know what the character for S looks like. But can you break that character for S? Can you break it down into something that,
can I maybe jump in here to clarify? I randomly got those letters, but a shorthand that I'm deciphering right now has, for instance, one character written with an upright line and another written with a slightly tilted line. And because it's all in handwriting, you never quite know if maybe it's up, maybe it's to the side. And there are big consequences. One is S, one is T. But that's just one example. There's also, if you combine the T with an R, then you get the sign that means K. So is that a K or is that a TR? That's the sort of thing that, you work through it, you guess, you assume that like the word is probably this given the context. A KR is less likely than a T, but I wonder, your computer assisted approach would help. And I'm just wondering.
No, I think not with that. I don't think. I mean, that's everything I was saying was after you have a transliterated verse, which I think, I mean, logically speaking, I think that's something that is work of transliterating. It's something that only a human expert who actually has a lot of expertise with this kind of topic. So potentially Hugo.
Yeah,
and Claire. They are the ones that are able to make the judgment, okay, this inclination of 45 degrees is meaningful or not, right? And if I do take this rotation of this character as a meaningful item, then I have to write it down in my log as one of the assumptions of this method, because I might want to go back and change it. So I think it's that's probably the hardest part. Even though, I mean,
can I jump in? Can I jump in?
Sure, of course.
I don't want to be an expert. I mean, Claire and I aren't the experts. I think I mean the analysis you've all done is correct, but the point is that we can only really get these collective we need possible interpretations, as many as we possibly can have for a particular character. So the more people who provide possible transcription, possible ones, the better. So it really shouldn't be restricted to people who aren't even experts, because none of us are experts. We're really not. I'm really not an expert on this, I promise. I'm really not. And it's really, everybody can have a go. What do you think that character is? There's the Gurney manual. What do you think it is? And if you have 100 people giving 100 different interpretations, that's really good. I think that's a really good start. And then you can start to discuss, and then you can start to work something out. And that's what I really want to do with this project.
Yeah, and I think that we all see slightly different things, and our brains all work in slightly different ways. And so this is somewhere between kind of handwriting analysis and an artistic creativity, because of course Dickens was an individual, and in that sense he was idiosyncratic in many ways in terms of not only spelling and handwriting, but of course the way he used shorthand, and so that's an additional complication. And so certainly, you know, more eyes, more analysts, whether they are professional or whether they are less professional, will contribute to the solution of the issue. And with that, I'm afraid I'm going to have to move on to the solution. But I'd like, first of all, to thank you very much, Zhou and Andrea, for your tremendous insights into this fascinating field. So thank you. Thank you. I will applaud on behalf of everyone. Thank you. Thank you very, very much. That was really, really good. And I'm now going to hand back to Hugo and Claire for the announcement of the Decoding Dickens Prize.
Hi everyone, back again. There we are. I also wanted to say very quickly, just as an addition to Zhou and Andrea, that it's really important, before I'm going to talk about the prize in a minute, but I think it's really important that we get this initial glossary of characters that we really know what they represent. And if we've got a lot of those, and we've got a solid basis that Andrea was talking about, you know, you start with things that you know, and then you have 100 million possibilities for the things that you don't know, and that we separate those out, and we can work on everything. And slowly, I think that the ones which we don't know, the more hypotheses we get, and we can discuss, and gradually we'll build up something that we know, and this glossary will get bigger and bigger. That's that's the hope, but it does need everybody. The more people, the better. Okay, now let's go on to the prize. Now, if you missed my trailer at the start of the symposium, I mentioned that the Dickens Code has received an anonymous donation of £300 for the successful transcription of a Dickens shorthand text. The prize is not technically part of the funding of our Dickens Code project, so it's being hosted by the Dickens Project at the University of California, Santa Cruz, that many of the Dickensians will know all about. For those of you who don't know, the Dickens Project is a global consortium of 40 colleges and universities which supports collaborative research and teaching on Dickens and the Victorian age. And Claire and I would really like to thank the donor and the Dickens Project for their generosity and support for this prize. Now, the text we want you to transcribe is the one that we have just been discussing in this final session, the Tavistock letter. And there are two things that contestants will need to do. First, they have to transcribe as much of the letter as they can. Now, I say as much as they can because, as we've been hearing, it's very unlikely that anyone can transcribe the whole letter on their own. So we don't expect a complete transcription from anyone. Secondly, contestants should write a short one-page self-report on their own transcription process. Nothing too complicated, just saying what characters they found most difficult and what tips they would give potential solvers. This kind of information is really the most important information, and it will all be very helpful for us in the future. It's all to do with hypotheses. Things that are difficult are the things that will really make us progress in this project, I think. The deadline is 31st of December, so you have 5 months to do it, so that's quite a long time. And we'll be announcing the winner or winners in our final symposium next February. You can find the text itself and all the instructions for submissions on our website. So please go there and download everything. And please do pass it on to anyone you think might be interested. Remember, this isn't for experts, anyone, people who solve puzzles. Andrea was showing us just now the code from that killer in California. I can't remember his name. But that was solved by a husband, you know, the initial code was solved by a husband and wife sitting at home at the weekend. The FBI couldn't do it and they did it. So it's not a thing for experts, it's just the people who like this kind of thing. So that's what we want to do. Everyone should put their mind to it. Even if you get one character, you've done something for Dickens and for us. So that would be great. So best of luck with the transcribing, and I'm going to hand you now back to Claire.
Thanks, Hugo. So from first-hand experience, we know that deciphering can be very tricky. So to help you along the way, we're organising a series of Solve It Dickens workshops. They're free online sessions which will further familiarise you with the principles of decoding Gurney and enable you to have a go at deciphering a Dickens shorthand text. We won't be looking at the Tavistock letter in the Solve It's. This one we're leaving to you. However, we will be looking at some of Dickens' other surviving shorthand scripts. You don't need to come to the Solve It to enter the Tavistock letter competition, but we hope the workshops will help you on the way and recreate that wonderful sense of sociability that Tim and Hugo were talking about earlier on. I think puzzling is much more fun together. And you can find a link here on the slide and we'll drop it into the chat. So as we draw to a close, here's a reminder of some ways to get involved in the project. Tavistock Letter Challenge, the Solve It workshops, by joining our mailing list, following us on Twitter, or just by reaching out and getting in touch with me and Hugo. We would love to hear from you. So now we should say our thank yous and sign off, I think, Hugo. And we've got a lot of thank yous, haven't we? Firstly, to all of our speakers, it's been a tremendous, thought-provoking, really stimulating day, and we're so grateful to you all for giving your time and preparing so carefully and answering the questions so thoughtfully. I have to thank our chairs, our dynamic duo, Pete and Lydia, and a special thank you to all of our tech support behind the scenes. So Sophie and Miri have been working tremendously hard to keep this all running smoothly and making everything look great. We'd also like to thank Luca Bowles for his help with the graphics, some of these shorthand characters you can see here, as well as the terrific Dickens Code logo. And of course, the AHRC for providing the funding for the project as a whole, as well as our institutions, University of Leicester and University of Odger. Hugo.
Yeah, I just want to say a big thank you to everyone who's tuned in today. It's been great to see you all. And please continue to follow us, because this really is a collective enterprise. And the more people who are involved, to quote Tim, the merrier we will all be. So thanks very much.